Hello everyone, I am Dr. Rajesh and today I am again with you with my new topic on projectiles, and in this we will study Latus Rectum, vertex, focus, Directrix, axis of the trajectory of the projectile. And this is my companion in this lecture, and he thinks that projectile is fun to learn. So it is his thinking, I can't say anything, but if he thinks that projectile is fun to learn, we will make projectile as a fun to learn. This is our commitment in this lecture. From the last lecture on the projectile, we know that equation of trajectory of the projectile is given by y is equal to x tan alpha minus 1 by 2 gx square u square cos square alpha. Fine. Now we will try to make this as a perfect square in x square. So firstly we will make this coefficient as unity. So for this we will have to multiply both sides, multiplying both sides with 2u square cos square alpha by g. Okay, this implies that 2u square cos square alpha by g y is equal to x tan alpha dot 2u square cos square alpha by g minus x square. So make this x as positive by transposing the sides. Firstly we will convert this into sine and cos terms. It will be x sine alpha cos alpha 2u square cos square alpha g minus x square. Cos square to cos square cancel out. This will be x 2u square sine alpha cos alpha by g and minus x square. So one way is this one. Now this implies that we can also, instead of transposing the side, we are multiplying both sides by minus 1. This will also make coefficient of x square as a positive. So this is minus 2 u square sine alpha cos alpha by g dot x plus x square. Now you see you have to make the perfect square, and for the same, this is x square, this is twice into x, and this is like b. This is a is here, this is b, so its square will be added and subtracted. So this further implies that minus 2u square cos square alpha by g y is equal to x square minus 2 u square sine alpha cos alpha by g dot x plus u square sine alpha cos alpha by g whole square minus same will be subtracted sine alpha cos alpha by g whole square, and this whole will make the perfect square. Okay, this is further equal to x minus u square sine alpha cos alpha by g whole square minus u for sine square alpha cos square alpha by g square. This further implies that now transposing this, taking this into left hand side, we'll get u4 sine square alpha cos square alpha by g square minus 2 u square cos square alpha by g y is equal to x minus u square sin alpha cos alpha by g whole square. Now making this as plus and coefficient of y as 1, so I am trying to make this y as plus and its coefficient as a unity, so I am going to take this out as a common, so this will be common, implies minus 2 u square cos square alpha by g, so here will be y minus u4 sin square alpha cos square alpha by g square dot g by 2 u square cos square alpha is equal to x minus u square sin alpha cos alpha by g whole square. Now cancel out this, g will cancel out, this cos square alpha will cancel out, u square to u square will cancel out, so we will get, I am writing it over here, implies minus 2 u square cos square alpha by g y minus u square sin square alpha by 2 g x minus u square sin alpha cos alpha by g whole square. This implies that I am writing this in the left hand side, sin alpha cos alpha by g whole square is equal to minus 2 u square cos square alpha by g y minus u square sin square alpha by 2g. Now comparing this equation with this equation, x minus h whole square minus 4a y minus k, which is a downward parabola, which is a downward parabola. So this implies that h is equal to u square sin alpha cos alpha by g, k is equal to u square sin square alpha by 2g, and 4a is equal to 2 u square cos square alpha by g. So this is downward parabola, and what will you say? You will name it as equation number 1 and equation number 2. So this is downward parabola, and it has, this parabola has vertex at h comma k. So I am discussing vertex, something about the parabola 2 in general. It has vertex at h comma k. So the figure of the parabola is given by, this is the parabola and this is the vertex, this thing is the vertex, and it has coordinate h comma k. So vertex is having coordinate h comma k, and this is the focus. So you see focus is at the same horizontal distance, so its component h will be same. And you know that in case of focus, this distance, this much distance in this particular parabola number 2 is a, so this distance is a, fine. So this total distance is k, it is clear from here. This is k, this height total is k, and this much distance is a. So if I say that what will be the ordinate means y-axis, what will be the ordinate of focus, height of the focus will be k minus a. So if I write its component as h comma k minus a, h comma k minus a. So focus coordinates are h comma k minus a. Fine. So this is the focus coordinates, and vertex is already know, and latus rectum is equal to 4a, and in this case 4a you know is nothing but what will you be saying, this is 4a. So this will be 4a is the latus rectum. And what will be the axis of the trajectory? Look over here, this will be axis of the trajectory. Okay, and it will be equation x is equal to h, because this is the line at a distance h. So I say that x is equal to h is the axis of the trajectory or this parabola, that is given by x is equal to h. Fine. So next we will see what is the directories of the trajectory. From this figure we know that this distance is also a, because in case of downward parabola, if this is h comma k, so this distance where the focus is, this will be a, and where the directrix is, that will also be a at a height. This is focus and this is directrix. So this is a, and if this is a, this is a, this is k. Fine. So this total height will be, I say this height will be k plus a. So I say that if this is the line at a height k plus a, so this will be y is equal to k plus a. So if I say that this line is equal to y is equal to k plus a, so that will be the directrix of the trajectory, implies this will be y is equal to k plus a. So I have discussed with you all the parameters that we are required, that of trajectory. First is vertex. So if I say, and I will be using all these h, k and 4a. Now firstly I am going to write the vertex. Vertex is equal to h comma k. What is the value of h? This one. So this thing will be u square sin alpha cos alpha by g comma u square sin square by 2g. Now this can be further written as u square 2 sin alpha cos alpha by 2g comma u square sin square alpha by 2g is equal to u square, and this is sin 2 alpha by 2g comma u square sin square alpha by 2g. Here we will be using this h, k and 4a. So you will note it down, these values, and I should also name these values as the values number 3. So next we will be, with this we have calculated vertex, we have calculated. Let us calculate the latus rectum. Now we see latus rectum is equal to 4a. Latus rectum at two number place we are calculating latus rectum is equal to 4a, and we know that 4a is equal to, from equation number 3, is you can cos square alpha by g. So this is your latest rectum. Number 3, we are determining the focus. So focus was having coordinates h comma k minus a, and what is the value of h? U square sin alpha cos alpha by g, comma what is the value of k? K is u square. You can refer equation number 3, sin square alpha g, and what is a? A is 1 by 4 of 4a, and 4a is 2 u square cos square alpha by g. So these two are in. So you can refer, I have used the value of h, k and a. You can refer from here. This is the value of h that I have used, this is the value of k that I have used, and this is the value of 4a that I have used. Now we will be calculating the focus. So this is equal to u square. So this can be written something like, you can easily write cos alpha by 2g, fine. So this 2 will cancel out. Now this can be written as u square sin square alpha by 2g minus u square cos square alpha by 2g, and this can be written as u square sin 2 alpha by 2g. This u square by 2g is common, inside is sin square alpha minus cos square alpha, and this thing is further equal to u square sin 2 alpha by 2g comma minus u square by 2g. This is cos 2 alpha. So these are the coordinates of focus. So if we try to see what will be the location of the focus, so I'm going to draw this parabola again. Look at this figure. Here the focus can have 3 positions. This is the vertex. It can be above the x-axis, it can be on the x-axis, and it can be below the x-axis. So if this component is called ordinate. If the ordinate of the focus is positive, it is above. If it is 0, it is on the x-axis. If it is negative, it is. So this is the ordinate of the focus. If I say that if ordinate of focus is positive, when it will be positive, when this component, because it is already negative, this component is negative, is positive, then focus is above x-axis. And when it will be positive, if cos 2 alpha is less than 0, and when it will be negative, when 2 alpha is greater than pi by 2, because we know that in second quadrant cos is negative. This implies that alpha is greater than pi by 4. So if this is greater than 45 degree angle of projection, then the focus will be above the x-axis. This is the sub case number 1. B, ordinate on x-axis if this thing is equal to 0. On x-axis, if cos 2 alpha is equal to 0, and when is cos alpha 0? When it is pi by 2, implies when angle is 45 degree, the focus will lie upon the x-axis. Number 3, focus below x-axis. It will be below x-axis when this thing is negative. This is already negative, this thing is positive, so it will be below x-axis. So this will be, if I say cos 2 alpha is greater than 0, and cos 2 alpha is greater than 0 implies cos, and that 2 alpha is less than pi by 2 implies alpha is less than pi by 4. So this all is depending upon angle of projection, that with which angle we are projecting the particle. If angle of projection is less than 45 degree, focus will be below the x-axis, and if it is exactly 45, focus will be on the x-axis. If it is greater than, focus will be on above the x-axis. So this is the position and the location of the focus, that is depending upon the angle of projection. We have discussed in detail. So next we are moving towards the next coordinate, that is the axis. Axis, if I would again say what was the formula for the axis, you will see it is equal to x is equal to h, and Directrix y is equal to k plus a. So you will note it down. Now firstly we are going to calculate the axis, then we will calculate the Directrix. Now next point number 4, axis. Axis we know that is given by x is equal to h, and you know h is given by u square sin alpha cos alpha by g. So this will be u square sin 2 alpha by 2g. This implies that x is equal to u square sin 2 alpha by 2g gives the axis. Okay, now next we will calculate Directrix. Directrix, we know that y is equal to k plus a will give the Directrix. So I am going to put the value of k, and k you know is given by u square sin. This is given by equation number 3. It is all mentioned. You can note it down from equation number 3. And a is equal to 1 by 4, and 4a from equation number 3 is 2 u square cos square alpha by g. This will cancel out. So this is equal to u square by 2g, and inside is sin square alpha plus cos square alpha is equal to u square by 2g dot 1 is equal to u square by 2g. This implies that y is equal to u square by 2g, which is the equation of the Directrix. Here we see Directrix depending upon the velocity of projection only. So if I and it is independent of the angle of projection. If I say these are the axes, say we have particle and we have projected it something like that, and this is the Directrix. Fine. So it says that this equation, this particular equation says that Directrix, this Directrix, if I say y is equal to u square by 2g will be same irrespective of the angle of projection. If I project it with this angle, say this angle is alpha, and if I project it with some other angle, so in every case the Directrix will remain the same. It is independent of the angle of projection, and if we keep the point of projection same, the velocity of projection same, then the Directrix will always remain same in each of the path. For each of the path it will remain same. So this is what is the reference of this particular equation. So in this particular article we have studied the Latus Rectum, vertex, focus, Directrix, and axis of the trajectory of the parabola. So these parameters will be frequently used in the numerical problems that we will be discussing in the next lecture. So I think this lecture is really easy and fun to learn. So this is all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye. Take care. Bye bye.